How do poles and zeros appear on the S-plane? Imagine you're looking at a map of a control system's behavior. The S-plane is that map, with points that tell you how the system reacts. Poles and zeros are special points on this map. They are not just random dots, they reveal how the system responds to different signals. When you analyze a transfer function, which is a mathematical way to describe how a system processes signals, you find these points by solving equations. The transfer function is usually written as a ratio of two polynomials in the complex variable, s. The zeros are the roots of the numerator polynomial, and the poles are the roots of the denominator polynomial. To find where they are, you set the numerator or denominator equal to 0 and solve for s. These solutions can be real numbers or complex numbers. When you plot them on the S-plane, zeros are marked with circles, and poles are marked with crosses. The real part of these points tells you about stability. If a pole is on the right side of the S-plane, the system tends to be unstable. If it is on the left side, the system is stable. Zeros influence how the system responds at different frequencies, shaping the amplitude and phase of signals passing through. For example, a zero at s equals 0 means the system has a particular response at 0 frequency, like a steady state. Complex conjugate pairs of poles or zeros appear off the real axis, often in symmetric positions, which affect oscillations and transient responses. When engineers look at these plots, they get a quick visual understanding of how the system behaves. They can see if the system will be stable or if it might oscillate. They can also predict how the system will respond to different inputs by examining the locations of poles and zeros. In control systems and signal processing, placing poles and zeros in specific locations allows engineers to design systems that behave just right. So, in essence, poles and zeros are the system's fingerprints on the S-plane, revealing its stability and response characteristics at a glance.